Hello and welcome to the new video, and this video is about a duct fitting, which is this one heel tapped elbow. It's basically a T, so because it has this inlet and this one is outlet and that's a branch. So I have here two versions of this fitting. So one is heel tapped elbow R0 and the other one is simple heel tapped elbow. And I have loaded here into my duct fitting duct T's. So the T0, it is loaded with this. So I'm going to show you that what are the problems in this fitting and how I have rectified in this. So the heel tapped elbow R0, it doesn't work with the routing preferences and it doesn't report for the correct ASHRAE pressure drop calculations. And which I have fixed here in heel tapped elbow, and I'll show you both one by one. So let's start with this heel tapped elbow. So let's say I have this 20 inches duct, and then I have to let me try to, because here I have loaded in my routing preferences this T, which is 1.5 R0, which does not work with the routing preferences. So if I have, let's say, a branch of say 14 inches and I try to connect it, so it just messes this. So you can see that it doesn't work properly. And the reason for this is that because this outlet is not aligned centrally with the inlet, so it will always behave like this. So instead, what I have to do is that I have to load the fitting manually here, right? So, and I will just take it up to here and connect this manually, and then I can delete this duct, let's say, and then I will just draw this duct, and I'll draw the outlet as well. And there you go. So right now I don't have any airflows, so what I have here is I have simply made an air terminal, okay, just to bring in some airflow inside the duct. So I'm just going to introduce the air terminals here, and I'm going to put some airflow inside this. So it's going to be, let's say, 460 CFM, and here it's going to be, let's say, 390 CFM, and so my total pressure, total flow rate here will be 850. And as you can see that now my system inspector button is showing up. I'll click this and I inspect, and it's reporting the pressure drop. So let's see, I increase the airflow rate here. Let's say I change it to 530 instead. So it's still in this direction. And the thing is that if I choose the loss method coefficient from ASHRAE table, and if I try to edit this, so you can see that it's not selecting the proper table, right? So there are these two problems. Number one, it doesn't work properly with the routing preferences. You have to load it manually, and number two, it doesn't pick the correct ASHRAE table. So now next time what I'm going to do is that I'm going to make this other duct which I have loaded this heel tapped elbow, which works with the routing preferences. So I'm going to bring it, let's say, 20-inch duct here like this, and then let's say my branch is, let's say, 14 inches again. So here you can see that this duct is, now the thing is that I can adjust this both vertically and horizontally, so that I know where is my inlet and this is my outlet. So let's say this is my inlet, and I adjust my outlet to be, let's say, let's say 12 inch, okay, and then I create this duct, which is my outlet duct. Now the thing is that here right now the center is aligned, the outlet center is aligned with the center of the inlet duct, but that's not how it is should be constructed. Its outlet has to be some z dimension away from the inlet duct, and z is calculated by this formula. So what I have done, then I have made this like button, adjust outlet. So when I click this, it will adjust as per this z dimension, which is being calculated here as per the formula. All right, so now the thing is, I can introduce my air terminals here to bring in my airflows. Okay, and also the one thing very important to check, that if you want to do the calculation the way it is made here, that I calculate all the respective loss coefficient for the branch, outlet, branch and outlet, right? I have the airflows also here. So what I'm going to do, I'm just going to give some airflows. Let's say, oh, this is very less, so let's say I have this 870, and here I have 460, right? So this airflow should be the sum of both, and here if I see, so I have my 870 and 460, the one which I entered, and the inlet is being calculated using the sum of branch and the outlet. And now the thing is, it is calculating the loss coefficient tables, but since the loss method is still getting from the coefficient table, okay, and it's not picking the correct table. So what I'm going to do is that I'm going to just simply choose not defined. And now I have, and the one more thing that I have to check is that all of these ducts on all of three sides, the inlet, the branch and the outlet, they should be from the same system. So this is mechanical air system 1, this one is 3, and this one is also 1. So what I'm going to do is that I'm going to I have to delete the system number 3. For that I have to go to my system browser, and in the mechanical I have to just select 3 and just delete this. So once if you delete this, the filter being applied to the supply system is gone from this system, and now both of these, supply air 1 and this one is supply air 1. So what I'm going to do, duct systems, and I have to edit the system, and now this should be add to the system, and I can add this air terminal to my this system and then finish. Now all of these 3 are belonging to mechanical air supply air 1, right? So now I'll just show you the loss coefficients, how it is calculated as per the correct ASHRAE table, and which is also included in the calculations being done by Revit. So what we are going to do right now, so we are going to do the settings of this this fitting same as here in ASHRAE Duct Fitting pressure loss calculator. So my inlet is 20 inches and my outlet here is 12 inches, and the branch is 14 inches. So so the branch is 14 inches. I'm going to say 14, and the outlet is 12 inches. So this is outlet 12 inches, and my total flow rate here is, so which is here 1330. So I'll just write 1330, and the branch CFM, the branch is this, so the branch CFM is 870. So I'll just write this 870 and I hit calculate. So it's giving me the two loss coefficients, the loss coefficient of the branch and the loss coefficient of the outlet, so which is 0.52 and 0.08 respectively. So let me just see here if these calculations are getting done correctly. So you can see 0.52 and 0.08, right? So this is doing correctly. So this calculation is being done inside the family, And if you go and do the calculation here, you get to go to analyze, and here to click the pressure loss report, and then you just deselect one and select only the one which you want to do and generate. So I will write here, let's say AHU mechanical 1 whatsoever, and here is my pressure loss report. So you can see here that these two coefficients are getting used, and they are doing the calculation here. So I have my loss pressure on this side I have 0, and on this side I have 0.02, which you can also see from here. So I have 0 and 0.02. Alright, so but this way, I mean, you have to do it like this when it does not pick the correct pressure drop from here. So because it doesn't pick, no matter what you do or what you try, it does not pick. So what I had done, all the fittings, they have this loss coefficient table, right? So F21. So I have loaded not just this, but the extended version of this table for doing double interpolation inside the family, and now you get the correct pressure drops, right? You go to system inspector and you just get the correct pressure loss reports, the airflows are correct and everything. So that's it. I mean, it's a very good looking fitting. It just works perfectly with the calculations, with the routing preferences and everything, and even the distance of outlet away from the center of inlet. All right, so thanks for watching. Have a nice time.